All right. So this has been a smooth start. Hopefully everyone is able to hear me. So let's go ahead and begin the webinar. Welcome, and my name is Mark Ho. I'm here in the Vancouver office, and with me today co-presenting is Sapidis Separ in Calgary. We are both technical solutions specialists with Esri Canada's Industry Solutions Group. For those of you who haven't attended one of our webinars, we'll be recording the session, and we will email you the recording along with a PDF of the slides. And if you have any follow-up questions about today's content, please feel free to contact Sapidis or myself. If you have any questions about today's presentation, we're going to use the Q&A panel. So if you have a question, be sure to choose Ask All Panelists, type in your question in the box, and click Send. We're going to pause a couple of times during today's presentation to take your questions, and we're going to follow up some of your questions that we don't answer afterwards. So please feel free to type in your questions in at any time. So for today's webinar, we're going to focus on some of the common workflows and best practices to enable your 3D data into your GIS using ArcGIS Pro. First, we're going to show you how to create 3D layers using point cloud and two-dimensional data that you have. Then we're going to show you how to be able to share that 3D content through the configuration and publication of 3D web scenes. And finally, we'll wrap these web scenes together using these new web applications that you can build so that everyone can visualize and interact with your 3D work. But before we begin, I'm just going to do a really quick overview of the demo that's about to happen. We're going to focus so much on the demo today that we just want to do a quick little overview of sort of why we're building this and what tools are required to do it. So to begin, let's start with the concept of a 3D base map. So a 3D base map is the foundation for all of your work in 3 dimensions. So much like a base map that you're familiar with in your 2D mapping work, a 3D base map includes many of those same elements, but it also includes things like terrains and features above the surface that are represented in 3D, such as buildings and trees, as you see here in this diagram. So what is the process of building a 3D base map? Well, one tool that you can use right out of the box is the Local Government 3D Base Map solution. In essence, this solution is an ArcGIS Pro project that can be used to author high-quality 3D scenes. These scenes are organized in different levels of detail and will incorporate existing data such as point cloud data like LiDAR and your two-dimensional operational data like building footprints. Once authored, these 3D scenes can provide that foundation to provide a consistent geographic context. Now, the key to this ArcGIS Pro project as part of the solution is that it includes a series of tasks and tools that will guide you through the process of discovering and deploying your 3D content for your organization. These tasks also include guidance on how to be able to configure your maps and apps when necessary to meet your specific needs. Now, Sapidis is going to demonstrate the workflow of how to be able to use this solution, but I want to quickly show you where you can find this solution on the Solutions webpage. So if you go to solutions.arcgis.com, you can do a quick search for 3D base map, and in the results, we'll have that Local Government 3D base map solution that we just mentioned. Now, if you do a quick little peruse of the content of this particular solution, you'll discover what the requirements are. So you're going to need ArcGIS Pro, probably a later version 2.1 or the latest 2.2. You will need an advanced level of ArcGIS Pro to be able to perform what we will see today. And you'll also need to have access to the Spatial Analyst extension and the 3D Analyst extension as part of your desktop license. Now, if you want to be able to share your work, you'll also need to have an ArcGIS Online subscription, or you'll need to be licensed with ArcGIS Enterprise. Now, when you download this particular solution, what you're really getting is an ArcGIS Pro project file, so this PPKX file, and that's going to provide those tasks to be able to publish that basic schematic or realistic scenes in 3D. There's also a help page here, so if you want to go to the Get Started side, this will kind of walk you through what is the process of creating these different scenes. Now, once you have a scene, you do want to be able to share it to other people in your organization or perhaps throughout the world. So once you work in ArcGIS Pro to be able to do the feature extraction and the 3D editing and maybe importing some 3D models, then we're going to go through that process of sharing that in ArcGIS Online or ArcGIS Enterprise. When you do that sharing, it's going to create feature layers and scene layers that will be comprised of that 3D web scene. And then from that web scene, you can share it within a desktop application like Pro, or maybe you want to share it through a web application onto a web page or onto a smart device. So to give you some context of what's going to be built today in this demo that Peter's going to start in a couple seconds, let's show you the end result first. So this is a web scene that was built in Web App Builder for ArcGIS. And here is that 3D content that we're going to be building from scratch. And it features some buildings with some facades and some trees along with a base map at the bottom. And with your web application, you can include different widgets that can manipulate things like change the daylight position, the sun position, so you can see the impact of shadows on these particular 3D features. So that will give you a taste of the end result, but how do we get here? So I'm going to pass things off to Sapide, who's going to walk through the process of creating that 3D scene we just seen. Sapide.
Okay, thank you, Mark, for the introduction. What I wanted to show you right now is using the only building footprint and the last file that allows us to create such a 3D realistic view of our building footprint and trees. What I wanted to introduce right now, the last file. So the last file contains LiDAR point cloud data. LAST is an industry standard binary format for sharing airborne LiDAR data. As you see, I add the last file to my Arc Pro, and I wanted to visualize this last file different way. So I'm just going to the appearance and change the symbology based on the classification. It allows me to differentiate between trees and building and other parameters within our last file. To work and extend our work, we need to create last data set. In order to work with the last data set and work with the other tools that help me to create such a realistic view, we need to work with the task. When you download your data from the local government 3D base map, you will see that there's 3 different tasks available for you. One is the basic local government scene that gives you very basic 3D view of your building and trees. If you receive the last file that your point density is less than 1 meter, we recommend to use a schematic local government scene task. Next step for me is working and creating last data set. So the last data set allows you to examine last file in their native format quickly and easily. A last data set can store reference to 1 or more last file on disk. So what I need to do, I need to add my last file to create last data set tool and provide the proper coordinate system and let's to create the last data set. I already ran this tool and I create the last data set based on this last file. So when you look at the last data set in the property, is a classification last data set that allows you to look at your data based on different classes. Next step is going and create digital train model. The digital train model helps you to provide the only ground elevation for your starting your analysis. What I wanted to do, I wanted to go to the property of my last file and select only the ground point. And it helps me to create the digital train model from the last data set. So I'm going and save my output in the folder that's available for me. So I'm just going and create the one digital model and call it, for example, DEM. And I'm going and provide the sampling value. The sampling value is a very important parameter in this tool. I can find the sampling value through the property of last file. So if you open your last file, you will see the point spacing is available, and it's defining the number that you can put it in the sample value. Right now, the point spacing is a 0.2, and I'm going and add the number very close to this sampling value. So for this scenario, I'm just going and add it as a 0.4. If you make a less number, tool takes more time to create the digital train model for you. Next step is creating DSM. But before I create the DSM, there is an optional tool that I wanted to show you how you can use it to burn the polygon on top of your DEM. If you wanted your building footprint be burned over your DEM, there is a tool called Burn Building Footprint into the Digital Train Model. So you use your building footprint and your DEM to give an assurance to DEM that your building footprint boundary is defined. But because this is just optional tool, I will pass it, and I'm going and create the digital surface model. So next step for creating digital surface model, I want to go and look at the property of my last data set one more time. And for creating the only rooftop of the building and high vegetation and medium vegetation, I'm going and select only these classification. And I'm going and say, okay. And as you see, only LiDAR points that are allocated to the roof building and the top of high vegetation will be selected for me. Next step, I'm going and add the last data set to my tool. And I'm going and define the best location to store my data. Let's call it this time DSM. And save it in the proper location. Make sure your sampling value is the same size of the sampling value that you defined in the DEM. And I'm going and run the tool. So the differences between the DEM and the digital surface model is just based on the elevation that you represented as a ground point and the top roof of building and high vegetation. So next step is creating normalized digital surface model. What I need for this particular tool is adding DSM and DEM and calculate the differences between these two raster files. So I'm adding our DSM and DEM and make sure the new raster is saved in the location that you can access it later. I can call it minus, and make sure that when you are saving your final result is not more than 13 characters. Otherwise, tool will show you the error. So the subtraction between the DSM and the DEM right now is created for me. In this step, you may want to publish your raster data to ArcGIS Online, which for me is not something I wanted to do. I wanted to move on and calculate building roof form. So I wanted to take advantage of the digital surface model and digital terrain model and also the subtraction between these two and create the rooftop from our rasters. So what I need a building footprint, I need a DSM, and I need a DEM. Also, I need my subtraction between these two layers. Let's this tool run. And I wanted to talk about this tool a little bit more. This task calculates the fields necessary for the 3D enabling your building polygons. As a result of this tool, you will have fields such as building height, eaves height, roof form, base elevation, and roof direction. All the value that will be added to these fields come from terrain and the surface raster that you provided to this tool. These attributes are added to the output building polygon feature class, which will be written to the geodatabase. This feature class consists of all building polygons that fall within the extent of the input DTM. Your original building polygon layer is not altered by this task. Make sure your building polygons are within the extent of both rasters. Otherwise, only features within the extent are processed. As a result of this tool, you will see the different type of roof form. The roof form can be gable, flat, or shed. And sometimes when you run this tool, the tool cannot identify proper roof form for you. So next step is you right-click in your polygon that is created by this tool and go through the edit tool and modify the result of your roof form accordingly based on the community that you are working with. So I'm just going and turn off the last data set and waiting for the result of my polygon.
Hey, Sabine, this is probably a good time to throw a question that's coming in from our audience. And for some people, this might be the first time they're seeing a task. So maybe give us a description of what is a task, and are you able to import that task into ArcGIS Pro?
That's a great question. Task is a set of pre-configured steps that guide you through a best practice workflow. A task is like a recipe that you can create to follow the complex or unfamiliar workflow. Task can be configured and shared with others. So if the task is created, I can right-click in my task folder and import the task that is created by others. I hope I answered this question.
Yeah, absolutely. And what I love about tasks is that everything is contained in that one task panel, right? So all of the steps, all the geoprocessing tools, everything is in one place, so it's really easy to follow that workflow, those steps in the task. Hey, looks like something's come up. This is cool.
Yeah, that's cool. As you see, it's just only polygon is created for me. In this step, I wanted to go and just examine visually to make sure that the result of the roof form is correct. So if I go and look at the different roof form, you see that by information that comes from the building footprint and DEM and DSM, it calculates some different roof forms, such as heap or gable. I wanted to go and test visually for some area that I'm sure that this area, all this building, have the gable roof form. And I wanted to make sure that this tool calculated properly for me. So I'm just going and select one of these buildings, and let's look at it and see what's the result of tool. And as you see, it created as a flat. So right now is the best time, before I move on to the 3D-enabled building, to run this 3D-enabled building tool, I go in through the edit tool and do the mass editing or individual editing. I can go and change the different roof form for this particular building, and also I wanted to change the roof direction and adjust it to the 45 degree. As soon as you change the your parameter in the attribute table, you should go to the Edit tab and save your edits. Now I'm ready to go and visualize the 3D form of this polygon. So I'm going and run the 3D enable building. Before I run this tool, I'm going and drag this tool, feature to my 3D layer group. And I can go to the next step and take this building footprint and add the symbology layer that comes from the ISRI, from the package. So this package provides the LOD2 building layer file, and if your last file is based on the meter, choose the meter LYRX. And I'm going and run this tool and waiting to see the result of my 3D in my map. Next step is converting this 3D enabling polygon to the multi-patch. Multi-patch is a type of geometry in ArcGIS designed to represent the shell of a 3D object. So let's move on to the creating the multi-patch building footprint. So when I add the result of my building polygon that now is converted to the 3D, I'm going and select the grouping field based on the object ID. It's very important what field you choose in this section, because I wanted to be able to edit the result of my multi-patch individually, differently, so provide different texture for each building. If you wanted to edit as a batch, choose one of the other type of the group. For example, just choose based on the, group it based on the roof form, or group it based of the roof direct adjust. So it helps you to edit once for all of them. So next step, I'm going and run and create the multi-patch from this polygon that is created for me. I don't want it to go and publish it yet, so I wanted to go back to the task, and I'm going to through the edit and show you how you can give a realistic feeling to your feature. Let me go and zoom in to the feature that I changed the roof type from flat to the gable and look at it deeply. And I wanted to go through the edit and work within this particular building and give a realistic texture in it. In order to do that, I'm going to the edit tool, and I wanted to modify this particular building. One thing I wanted to do, I wanted to reshape this building through the vertices. Select your feature first and provide the vertices accordingly to your needs. I wanted to create a skylight for this particular feature. So I'm just going and add more vertices in this roof. And then just bring it a little bit high to give this feeling to this building. Next step, I wanted to go and give a better texture to this particular feature. So I'm just going and select one more time my feature, and I'm going and load the texture. I have already texture for the roof, so let's add this texture to the roof of my building. Let me add it to other side as well, and apply this texture. If you wanted to change the zoom level, for example, this particular roof, you wanted to change the zoom level, or you wanted to pan it and change the angle or rotate it, still you are able to play with that texture. So I wanted to modify the roof in this way. Let's add a texture of facade to your building. So I'm just going and apply another texture to my particular building. For example, I wanted to have this facade added to my building. So I'm just going and again zooming a little bit more to be able to see, and I'm just going and make sure that the zoom level is enough. So let's go and adjust the other part, and if I'm fine with this particular building and facade, I'm going and apply it, and let's add the other texture to the other part of this building. So for example, I wanted to go and give a feeling of the stone around the other part, change the zoom level if it's required, and then apply this stone feeling to your building. Okay, so I'm fine right now with this texture, and also maybe you wanted to give the feeling to your skylight. So I'm just going and select one of the skylights and make sure that I change this, texture accordingly if you are happy with this texture. So I'm ready to go for the next step. So I'm just make sure that I save the result of my editing first, and next go for the creating the 3D schematic trees. In order to create the 3D schematic trees, I wanted to go and run the vegetation extraction tool. What I need in this particular tool is adding your last data set to your tool. You need your DEM. So DEM provides the information where is the location of your trees. And also, you may want to add the building footprint just for the assurance that your trees doesn't pop up, overlap with your building footprint. And you may want to define the buffer distance accordingly. Make sure that you choose the vegetation class code. How I can get this information? When you open your last data set, you will see that the classification defines the high vegetation and medium vegetation for you, which is the classification right now is the classification of 5 and 4. So let's add the 5 and 4 for the classification and run this tool. Usually this tool takes less than a minute to be run and give you a 3D point and a 3D 3D form of the trees as a result. But after this step, I wanted to go and create realistic feeling of the trees to my map.
Hey, Sapide. So while this is spinning up, got another quick question for you.
Yes.
Someone was asking about what version of LAST files are supported with the ArcGIS platform right now.
That's another great question. ArcGIS platform usually supports version 1, 1.1, 1.3, and 1.4. The other version is not supported within the ArcGIS platform, but in ArcGIS Pro is the same. So we just support the version 1 to version 1.4.
Yeah, and I just want to mention, too, all that cool things you did with that building where you added in the textures and the multi-patch, that's all brand new to ArcGIS Pro 2.2. So there's all these new interactive tools to be able to make your buildings more realistic. It's all being added in at the latest version. Exactly.
Another thing I wanted to mention, if you, when you're running the 3D created 3D trees, the important part is sampling value. If the sampling value is less than 0.3, it gives you more trees. If your sampling is more than 1, it's just that you will receive the less trees. For this scenario, I received only very few trees because I didn't put the sampling value as a 0.4 just for the sake of time, because we wanted to just show everybody how easy they can create the trees. So right now the trees is created, our 3D building footprint is created. Next step for me is going to publish the result of my analysis as a web scene to ArcGIS Online. If I wanted to do the rest of the process, the best practice for now is insert the new local scene. The reason that we create the new local scene is because we wanted to change the coordinate system of the new scene to the coordinate system that's acceptable by ArcGIS Online. So I'm just going and get the only features that I'm interested to publish to ArcGIS Online, which is, for me, is the 3D of trees and also the final building footprint. So I'm just going and take only these two multi-patch feature and add it to the new scene. And I'm going and share the result of our work through the web scene to the ArcGIS Online. Before I proceed to publish, I have to go and change the coordinate system of my new scene to the coordinate system of WGS 9084 Web Mercator Auxiliary Sphere. That's the coordinate system that's acceptable for publishing our feature to ArcGIS Online. I'm going and provide the requirement for the summary and the requirement for tags, and I will go through the analysis. The analysis tells me that if there is any error during the process of publishing the result of my work to ArcGIS Online, it will be show up as a warning or as an error here, so I can go and fix it. Right now, there's no error pops up, and I'm able to share the result of my work to ArcGIS Online. So, okay, I have to go and change the name of the layer to something that is more meaningful, and run the tool. I'm just going in analysis one more time, and I hope that this time sharing works. Okay, during the time that the sharing is going to be run, I'm going through the ArcGIS Online because it takes a few minutes to publish it as a result to ArcGIS Online. So let me go to the ArcGIS Online right now and show you, if you wanted to publish it, what will you get as a result. Okay. I'm going to ArcGIS Online. Under the Content tab, you will see you will have the folder that is created by the process of publishing the result of your work to the ArcGIS Online. As you see, ArcGIS Online gives you a hosted feature layer for your building and the hosted feature layer for the trees. Most important things that we need is creating web scene for us. So let me go and open the web scene that I created as a result of publishing our work to ArcGIS Online and open it in the scene viewer. So this is the same scene viewer that Mark, before we start our process, showed you that that would be our final result. As you see, I went through the editing tool and provided texture and facade for the small portion of our community. And I'm able to look at the result of my work with the web scene. As you see, I'm able to change my base map to the something that gives me a more idea about my work. And also through the web scene, you are able to change the daylight and the shadow that that is required to give a more realistic sense to your features. Next step is sharing the results of your work as a web app. So I'm just going to the web app. As you see, there's a lot of templates that are available. You can embed your web scene with these templates, or you can share the result of your work through the web app builder. So I'm going and accept the web app builder, and I wanted to add some widgets to give them more tools for running and visualize the result of my work. So I'm just going to the widgets and add some more widgets. For example, I wanted to add a widget as a share, search tool, measurement, and like a base map. Maybe if there's something I needed, I will add it and it will be added to the ribbon. I save the result of my work and the launch of my work, and I'm able to share the result of work with my coworker or other stakeholder. So right now we are done, and I pass it to Mark.
All right, great. So a lot of things happened in the last few minutes in terms of creating that 3D content. Let's kind of do a quick recap of what we just saw, and we're going to revisit these slides that we showed you a little bit earlier. So what Sapide did was take some existing LiDAR data with some building footprints and then use that task as part of that local government 3D base map solution to be able to establish the elevation, to be able to determine the roof types, and to be able to create those 3D buildings and those trees by extracting those features from the DTM and the DSM, be able to create all of these different features. Now, as a part of the local government 3D base map solution, all of these features are being stored in a local government information model. So it's a predefined geodatabase that will create these features and store it in a central place. So it makes it really easy to be able to manage all of these features that you create. And at the end, you're going to use these procedural rules to be able to define these features in more detail. And depending on the level of detail you want, it can be something very basic where your 3D buildings are going to be a bunch of blocks. It could be something in the middle like Sapide did with today's demo. We can use a schematic scheme to be able to include things like different roof types, a little bit more deep level of detail in those features. Or you can go all out and create realistic scenes where all of your buildings will have some facades and will look as realistic as possible. And then once you create that content, you do want to be able to maintain that 3D base map. So you can use ArcGIS Pro to be able to continue to make edits to your features like we did to that one building, to be able to take that one house and add its own unique facade and be able to edit some new features like that skylight. You can do all of that and maintain that database within ArcGIS Pro through editing. You can also import features as well. So maybe you have some existing buildings that exist from other forms. You can bring that into your Pro project as well. Once you have that 3D base map, then you go through that sharing process that Sapide walked through. So you can use ArcGIS Online or ArcGIS Enterprise, be able to create these feature layers and these scene layers that will be comprised into this web scene. And then that web scene, you can build something like an application in Web App Builder for ArcGIS to be able to share that content. So just as we have a few extra minutes here, I do have a few more questions, so hopefully we can go through some of these right now. So a question, Sapide, came up about how to be able to visualize this 3D data. So when you visualize your 3D data into these 3D scenes in Pro, do we need to have a 3D Analyst extension to be able to view them?
I appreciate this question came up. To visualize 3D data into 3D scene in ArcGIS Pro, we don't need any extension. Hopefully, you can just add your any 3D data that you have and visualize it in the 3D scene without needing any 3D Analyst extension or any additional extension.
Excellent. Another question has come up about other solutions in 3D. So primarily we focused a lot on using ArcGIS Pro to work with 3D data. What other solutions do you have that you could recommend for working with 3D data, especially for the developer like this person who's asking the question is?
For developers, if you're looking for extending your GIS work into 3D, you may want to use 4X series of ArcGIS API for JavaScript to build the 3D web apps. That's our recommendation for the developer. But there is another very good software called CityEngine that we recommend you to use it. And it lets you create 3D city space, but is limited only by your imagination. For more inspiring, maybe you wanted to browse ready-to-use scenes in Living Atlas of the World. The new software is ArcGIS Urban, and I recommend that search for it and see how you can use the 3D view in this particular new product.
Yeah, ArcGIS Urban is going to be a pretty big thing. It's sort of in beta right now, but we're beginning to roll out that beta in the next few weeks and months. So that is definitely going to be a very cool tool, especially for planners, to be able to use 3D data to be able to help solve problems and provide different scenarios for planning purposes. So that's something to be really looking forward to in the future. So Peter, got a couple more questions here, and hopefully we can tackle these together. One question that was really interesting is about credits. So the question is, how many credits are we using in these examples? Just concerned that there might be, that the over-processing of this LiDAR data with large file sizes will impact on the number of credits. So I guess the first question is, are we using any credits in the demo that you just did?
When you are publishing your work to ArcGIS Online, so for hosting your feature, like a hosted feature layer, yes, you use the credit, but the credit that you use it is not that much that make you concerned about it. So anything you host in ArcGIS Online, use credit. But because you publish as a hosted feature layer and web scene, and you store it there, the credit that it will be consumed is not. It's very, very small. So I can go for the number right now because there's nothing in my mind, but when you search in the Google and search for the credit that it will be consumed in ArcGIS Online, you will see the hosted feature layer, how much it consumes the credit and the web scene.
Yeah, so that's a really good point to reiterate. So the actual execution of the tools that you use in the task, those did not consume any credits at all, right? You use Spatial Analyst, you use the 3D Analyst extensions to be able to run those tools. You didn't need to use any ArcGIS Online credits to be able to perform those tasks, correct?
Yes.
Correct. The only time credits are an impact to this is the storage of the features in ArcGIS Online. That will require some storage credits, but as Sapide mentioned, it's actually pretty minimal. You can store a lot of data for a minimal number of credits per month to be able to share that work with others. So that's an important distinction to make. I know we started a little bit late and we're at the top of the hour. I'm just going to tackle a couple more questions and then we'll begin to wrap up. So Sapide, another really interesting question here is about LAS files and the size of LAS files. So is there such a thing as too big a file for a LAS file, and is there any limit to the size of your LAS files?
It's an interesting question. When you receive the LAS file, usually the LAS file contains LiDAR point cloud data and can be very heavy. But the beauty of our software is you don't need to use the binary format of the last file. You convert your last file to the last data set to start your process. And last data set can contain one or more last file and is just working the way that compress your last file in the way that you can use it very quickly and easily. So when you receive the last file, even if it's very huge, when you convert it to the last data set, it helps you to run the tool very quickly and easily.
Excellent. That's great. And now I know there's a few more questions online, but we do want to begin to wrap up the process. The nice thing is that we have recorded your contact information, your email. So either Sapide or myself, we will contact you directly to answer those questions that we didn't get a chance to answer today. So if you did ask a question, thank you so much. We really appreciate it, and we'll address those offline after today's presentation. But let's begin to do this wrap up. So as we saw in today's demonstration, you were able to use ArcGIS Pro to be able to create a 3D base map, which comprises of these 3D layers, and you can build them from LiDAR data, as well as some building footprints, be able to derive those features very easily using the task-based project that you could download from that solution site. From there, you went through the process of publishing those 3D layers and building web scenes, and then from those web scenes, you can create web applications to be able to share your content over the web. So there are a number of solutions or resources that we provided for you on this page. Following this webinar today, you're going to be emailed a copy of these slides, so if you want to use these hyperlinks to access these resources, you can go ahead and do so. Included here are the direct links to the local government 3D base map solution that we showed today. So if you want to start downloading and doing this, you can certainly do that. There's also a second solution that's on that page that will help you visualize proposed developments and assess the impact of each of these new developments on an existing community. So that's another cool 3D solution that's provided through that solutions.arcgis.com page. Another thing I want to mention is that Esri Training has recently introduced these new learning plans. These are created by curriculum experts at Esri and by the GIS community. So you can enroll in this specific 3D focus plan to learn techniques to determine visibility between vantage points on a given line of sight or maybe across a viewshed surface. So if you really want to learn more about how 3D analysis can be performed, this learning plan might be a good place to start. Finally, the Learn ArcGIS website includes a hands-on lesson to create realistic 3D forms from LiDAR data. So a lot of the process that you saw today, you can actually use this Learn resource, this exercise, to be able to do it with your own data or with the supplied data. And you can walk through the workflows of being able to use real data to build elevation layers, to be able to create and edit 3D buildings, and to export those features. So we really encourage you to use that Learn ArcGIS page to be able to learn more details on that. All right, so the summer's winding down, which means the webinar schedule is going to start heating up in the fall. So Esri Canada is going to be bringing you a series of really interesting and relevant webinars in the coming weeks and months. So coming soon, we've got some webinars that are focused on crime analysis, on utility networks, and with mobile maps integrating with CityWorks. And this is just the beginning, tip of the iceberg. We've got a whole bunch of webinars that are coming up over the next few months, so we really encourage you to keep up to date with these webinars coming up. We also want to highlight the Migrating from ArcMap to ArcGIS Pro instructor-led course. We know that many of you are still transitioning from ArcMap to ArcGIS Pro, and as you can see from today's demo, there's a lot of cool things in ArcGIS Pro you might want to leverage, especially things like tasks, which is a very cool component and will be advantageous to your organization. So if you haven't had a chance to jump on the ArcGIS Pro train, this 2-day course will get you to that station really quick. So really encourage you to take that training class as well. And finally, you can always connect with the latest at the Esri Canada through our Twitter feed and our Facebook page. So like us, follow us, be a part of our community. So with that, we'd like to thank you for taking your time out of your day and participating in today's webinar. We're going to email you a recording of the webinar shortly, as well as a PDF of the slides. And additionally, we're going to post the webinar recording to our archive page when it's ready. We also really like to get your thoughts on today's presentation, so please fill out the survey that comes up when you exit today's webinar. Or if you have any follow-up questions or you just want to contact us one-on-one, there's our email addresses on the screen. You can go ahead and shoot us an email, and we'll be happy to respond. So with that, we really appreciate your time, and we really appreciate your patience as we had a little bit of a rough start. But thank you so much for tuning into today's webinar, and we'll see you down the road. So, PD, any final thoughts for the crowd today?
No, but I appreciate your participation in this webinar. Thank you.
Great, thank you so much. So we're going to stop the recording, and again, if you have asked us a question from today's webinar, Zapita and I, we have your contact information. We'll follow up with you directly on those questions. So with that, thank you very much for tuning in today, and we will see you again this fall with more webinars down the road.